Good afternoon, and is my microphone on? Can you hear me? Good. Okay. Welcome to the last session of this year's NIC, and thanks for coming along. I thought for a moment I was going to have one person in the room, which was fantastic because it would either be a very well-rated session or it would be a disaster, one or the other. Yeah, it'd be 100% one way or another. Anyway, thanks a lot for coming on. What I want to do and cover in this session is really my experience of troubleshooting ADFS and the Web Application Proxy. Obviously can't show you absolutely everything, so what I want to do is try and give you an approach to troubleshooting this and some of the tools that you might actually use. So I want to start off, as I always do, is just going through some of the key concepts so I can refer back to them when I'm doing the troubleshooting to say it's not doing this or it's not doing that. So we're going to go through, so if you've seen those slides before, apologies, but it's really important to set the scene on this session. Certificates and trust, SSL bindings are very important. We're going to be doing some advanced troubleshooting using Fiddler. And then I'm just going to mention briefly using security auditing and then troubleshooting the web application proxy itself. Warning, just always test and document everything. One of the best ways of breaking a system is to turn on all of the possible logging that you can and then forget to turn it off again. Before you know it, log files are overflowing, the things are slowed right down, so be very, very careful. And so much of the work I've been doing is from direct field experience. And I can tell you what occurred when we were troubleshooting. Obviously, you need to apply that knowledge appropriately into the environments that you're troubleshooting. But hopefully, I can give you the correct approach. So key concepts, the idea here, we got a user wants to access the application X, which is our relying party, and what we're going to do is go and authenticate ourselves with a security token service. Having done that, we will get a security token, and that security token will have claims on it appropriate for application X. Now, what goes on there is purely up to you to design. And having designed and chosen what's on there, you've got to make sure they're actually there. So if you're troubleshooting and it's a problem with an authorization access, it could be that you've got the wrong claims. So you will need to validate that. Particularly when you're working with partner organizations, you do get the wrong claims sent across. It's about trust. We're establishing trust. We're establishing trust between the user and our front end. And I've shown it as an STS. It will be an STS including a proxy if we're coming from the outside. Right? But we're going to have an SSL communication certificate, which is terminated. We will then have a security token that is issued. That security token is going to be digitally signed. And the signature on there will require the public key to be on the security token service. To validate that signature, the relying party needs to know about the public key details of that particular certificate that was used for signing. So somehow that information has got to get down there. If we're going to encrypt, and when we encrypt the token contents, so the claims, then we will need an encryption certificate, and the public key will be up on the security token service, and the private key will be down on the relying party or the application. Now, what type of certificates do you use? Almost absolutely essential to use public certificates for the SSL communication. Because even if you're doing it just for your own company and you're only doing it internally, then there will be a time when someone says, we want external access to this, so you'll be putting in a proxy to do it. And then there will be a time that someone says, well, we want partners to come in and give them access to our applications. And therefore, if you've got a public certificate right from the start, you don't have a problem. But bear in mind, if you're not going to go public, you're going to have to distribute root certificates to all your clients, and you will somehow have to get the clients getting hold of the CRL, the certificate revocation list. That is if you've published one inside your, if you've published a certificate revocation list path inside your certificate. As I say, simplest thing there on that side is to use public certs. Now, what about the certificates used for signing and encryption? Those are best left off as self-signed. And some people throw their hands up in horror and say, you can't use self-signed, they're not secure. And if you think about a public certificate, why do we have an SSL cert? We have an SSL cert sitting on a server, so when a client connects to it, it's validating the URL it's going to, right? Because the certificate matches the URL. So this guy, the server, gives the certificate down, and the client needs to validate the certificate. All right, so what this client does is it checks it's a root, and it also checks if there's a certificate revocation list and path that it can go and get the list from. Okay, so that's in this situation. But when we're dealing with ADFS and we're dealing with security token service and relying party, we establish the trust right at the beginning. So we're basically saying this relying party, we're saying you can trust this signing certificate. Right? So it knows about the certificate and it will identify the certificate by the thumbprint. So if the wrong certificate was passed, it would say that certificate is no good to me. All right? So we don't need to go to root to validate the certificate. We know it's genuine because we can validate the thumbprint. Right? And equally well, if we don't need a certificate revocation list, because if you revoke the certificate, the trust is lost instantaneously. Right? There's the only reason we have CRL lists is that if we're in a sort of environment where we've got a SSL server and we've got a client, the client can't be informed that that certificate is duff. All the client can do is check a list to see if it's been revoked. Right? Whereas in this situation, as soon as that cert's gone, then the signing, that signing is no longer valid. The advantage of leaving them as they are is they auto rollover. All right, and you don't have to worry about the certificates being renewed on the ADFS server. However, what you will have to worry about is how you tell your applications and your relying parties that the certificates rolled over and you need to update the relying parties. And that is one of the things is when you deploy ADFS, you should work out how am I going to update the relying parties when the signing certificate rolls over on the ADFS server. And what some people do is rather than using the lifetime, the default lifetime, they set the signing certificate with a very, very long lifetime, knowing that at some point they need to roll the cert over, but also knowing the lifetimes, the actual auto rollover will happen so far in advance they don't need to worry about it. Because the worst thing that can happen to you is it auto rolls over and you're not prepared for it and you haven't done your thing. So self-signs for those, public for the front end. And by the way, CNG certificates are not supported. So if you do decide to put in your own signing certificates, your own encryption certificates from your own CA, do not use CNG certs. In terms of creating trust, we have a bunch of details about the security token service and the relying party or the application. And the relying party needs to know about security token service, and the security token service needs to know about the relying party. And we need to exchange that information, and that information is exchanged when we establish the trust. And the best way of doing it is with the exchange of federation metadata. So there's an XML file that describes all the information, and we take the STS one, give it to the relying party generates one and gives it up to the STS. But again, if your metadata goes stale, that can cause you trouble as well. So where does the metadata get stored? On the security token service, on our ADFS server inside the database. On a web client, it will be stored inside the web config file. That's a standard place to actually have that information stored. How does the WAP and the ADFS work together? There's trust involved there as well. So when you install the WAP, what it will do is it will create a self-signed certificate, right? And it will use that certificate to authenticate to the ADFS server, right? And what will happen is that somehow this certificate on the Web Application Proxy needs to be placed into the database on the ADFS server. That's done, right, by giving the WAP installation the credentials, the local admin credentials on the ADFS server. And then it can write the certificate into the database. Right? After that, we don't need those credentials anymore. It's purely done by the use of the certificate, and this guy renews the certificate before the previous one expires and writes it into the database using the permission or the authentication provided by the original cert. So if you're checking your self-signed, if you look in your local computer store of the WAP, it's there. If you look in ADFS, what will happen is it will be written out of the database or copied into the trusted devices node of the certificate store. So you can check that it is also there. So if you get a problem with the relationship between the two guys, then you can check in the locations for the certificate being there. Okay, SSL binding. Traditionally, our binding has been bound to an IP address. So it's an IP address port number, and that's where the cert binds. The problem is we cannot bind multiple certificates to the same IP address, right? However, what we can do is use server name identification. So server name identification is a bit like a HTTP host header. But during the initial SSL setup, during the hello part of the protocol, what it does is the client will have an extension that says, I support SNI. And then the client will actually pass over to the server the host name that it's interested in. And in that way, the server can give back the appropriate certificate. So we can now have multiple SSLs on the same IP using SNI, right? Whereas previously, we could only have a single SSL cert bound. Both ADFS and the WAP use SNI. And if you look for it, you won't find any websites. What you will find, though, is http.sys, and you can look at the binding on http.sys. So what if you have to support non-SNI clients? And why might you want to support them? Well, you may well find that older browsers and legacy operating systems are using non-SNI. I've also seen it on hardware load balancers and other network appliances. Now, most hardware load balancers, most network appliances, you will be able to configure them to use SNI. But if you're failing to connect to your ADFS server, or you're failing to connect to your Web Application Proxy, think SNI, and that may be the problem, right? The easiest way of finding out if there's a problem is to actually look with a network trace, and I'm going to show you that in a moment. But as I say, it applies to both the connections to the front-end proxy and also the ADFS server. I'm always asked about SSL bridging. So SSL termination between the client and the WAP. Is that possible? Well, what it will do is it will break workplace join. So the answer is sort of yes and sort of no, right? So this is, we've got the Web Application Proxy, we've got the client out here, right? And what we're doing is in some network device, we're doing SSL termination. And then we're bridging and reconnecting SSL to the other side, right? That will work except when we're actually attempting to do a workplace join. And if we're attempting to do a workplace join, we will not be able to do it. Can we do it between the WAP and the ADFS server? And the answer is absolutely not. So if you've got the WAP device here, what you'll have is a WAP farm, and then you'll have an ADFS farm. and you will have a load balancer in between. And what you can't do is SSL termination or bridging. So you can't terminate the SSL and then recreate the SSL, because what it will do is it will break the authentication between the WAP device and the ADFS device. All right. And then finally, the WAP and the publish server, absolutely, we can do that. So we've got the publishing server down here. We've got the WAP here. If you want to, you can certainly have a network device which is actually doing SSL bridging. Or it could, in certain circumstances, if the back-end system is not claims aware, it could actually do SSL termination completely. That's a possibility. But this question always comes up when we're deploying these things. People are having problems, and when you go and sort of analyze the problems, it's quite often to do with the HTTPS being terminated and bridged. So bear that in mind when you're trying to look at a system that is not working. So there's my demo environment that I've got. I've got my pretend internet. I've got corporate network with a proxy, an ADFS server, a domain controller, and in this particular case, a single server running a claims-aware application. And then I have a partner organization sitting there as well, just in case I needed it. And I've got what I call my ISP DNS, which is my DNS server for the cloud. And obviously my DNS server for the internal network is also the domain controller. So what we're going to do is look at SSL certificate binding, and I'm going to start off on my client machine, which is sitting currently on the London network. And what I'm going to do is I'm going to go to my client claims app, and I'm logging on adfs.example.com. So we're actually connecting to the ADFS server. I'm going to put in my credentials to go in there. And we're in, and we can see our claims. Okay, so everything's working beautifully. And coming down here, we can see inside corporate network equals true. And this is an exact scenario that one of my customers threw at me. He said, okay, we've got it all working. We've got a few legacy Windows XP boxes, but they just can't connect. So let's have a look at that. And where's my legacy XP box gone? Looks like it's probably that, which it is. So here we go. And that's the situation. Okay, any ideas? And you can't make XP connect. So what have we been talking about? Certificates. All right. XP will not do SNI. All right. So server name identification, it cannot do. It doesn't have that capability. So here's a sort of classic example of the thing failing. And what I'm going to do is I want to show you how you can very quickly detect this. If I go to my ADFS server, which is over here, what I can do is I can run up Wireshark or any network monitoring program, and we'll start that away. And so Wireshark is now capturing, and I'm going to go back, and I'm going to, with the Wireshark running, I'm going to go over to my XP client and try connecting again. Right, let's go back over here and let's actually have a look to see what's happened. Let's stop that and let's put in here as a filter SSL. Okay, and apply that. And what we can see is we've got a client hello here. All right, so if we look, we've got a, let's do that. We've got a client hello. That's the start of the SSL communications, but there's nothing more beyond that. Okay, and if we have a look at this, the giveaway is if I turn off this filter, so I clear the filter for the moment, we've got the client hello, and immediately we get a TCP reset. All right, and if you see that TCP reset immediately after the client hello, it's almost certainly that it's an SNI problem, because basically the client is trying to connect and it's being told, I don't have a certificate for you, so the connection's being reset. Right? And if you look, you can actually drill in here, and you can see, if you go in under the SSL, well, you should be able to. What's going on in here? So if we go in under, there we go. Oops, come on. Click. Click. Under here, there is no SNI extension. What does an SNI extension look like? Well, if we just go and start this capture again, so we'll capture on here, so continue without saving, and we'll just go back to my other client, and I go to claims. In fact, let me close that and go into claims again. And what we'll have here, when it gets, so actually it's probably, I probably got enough from over here. Let's put in SSL in here and apply that. And we've got the hello, and if we look down here under, I'll expand it and then I'll push it up onto the screen. We have an extension which is server name, and the server name identification is displayed there. So we can actually see, so we've got the SSL extension in there. Okay, if it became absolutely essential to support a non-SNI client, what you have to do is you have to change the way the certificate is bound. Recommendation is, wherever possible, enable the SNI client capability. But if you absolutely needed to do it, what we can do is we can actually go and, first of all, what we'll do is we'll start up PowerShell, and I need a command prompt, so I'm just going over to a command prompt on here, and what I'm going to do here is a netsh, and I want to actually go to the HTTP context, and I want to show SSL cert, which is going to show me my SSL binding. And if we look at that, all the binding is host name port. There is no IP port binding in there. If you want to support the non-SNI client, then what we need to do is, in fact, I've got it, no, I haven't, not in that file, I've got it in another file, save me typing the command in. No, it's not that. What's going on here? Oh, yeah, no, yeah, here we go. Let me come down here. And we need a command prompt. Just pop that in there. And what this is, let me just run that. And I'll go back over here, show the SSL cert. And what we've now got is we've got a binding of the port 000443, so onto the IP, and we've got the certificate hash. The certificate hash is the same hash that was used here, and we've also got the certificate hash there, same as that one. The client or the app ID is the same app ID as well. And just to go back onto the command, what it is netsh add SSL cert, the IP and port number, the hash which identifies the certificate, and the app ID. And now if we go to our client, what we should find is that we're now, well, it already looks successful, so we can log in example in here. And we're in. Now, I'm not advocating that we all get XP clients working, because hopefully there aren't any in your organization anymore. But what I wanted to show you is I've had customers spend hours of grief with network appliances and health probes and things that will not connect. And with a very simple network trace, you can just look at it and say immediately, it's probably SNI support, because what you see is that hello, and then you get immediate TCP reset after that. So do bear that in mind, and do remember that one. Oops, wrong direction. So let's move back to the slide deck. So the next thing I want to do is actually looking at recognizing WS federation on the wire. So here we get our user, hits the claims aware application. The claims aware application says, I don't know who you are. Go and try and authenticate with my STS that I trust. So the trust is between that client and the STS. So we get a redirect that takes us up there. If that STS trusts other STSs, you'll have a thing called home realm discovery at that point. Otherwise, what will happen is we will authenticate the user, and we will provide a token that is trusted or signed, digitally signed, for the claims aware application. And I'm going to send the token across. Having sent the token across, we can then render the page. That token will actually authenticate against the server. So what I want to do is just look at that little piece there, so we can actually recognize it on the wire. You can do an awful lot of troubleshooting, just being able to look at the protocol and identify what's going on. So the first thing that happens is it does a redirect. So we hit our web application, it does a redirect. Where does it do a redirect to? Up to the security token service. So what we'll be looking for when we examine the redirect, are we actually going to the correct endpoint on the security token service? Because if it's not, you can immediately say the web config file is incorrect, has the incorrect configuration in it, because that configuration is coming from the website. All right? The next thing it says after that is it wants to do a sign-in, and this is actually using WS Fed. All right? All protocols are similar-ish in terms of how they operate. All right? So once you understand how one protocol works, you can normally figure out what's going on with the other protocols as to where there are problems. So the next thing is, what it's saying is sign me in and give me a token for WT realm. So that is the identifier of the relying party, and that will be inside ADFS as the identifier. Next thing is WCTX, and what WCTX does is it remains unchanged between your request for a token and the reply. And if you think about what might happen is you might have a website suddenly hit with 50 authentication requests, 50 redirects up to the security token service, right? One after another, 50 replies, and somehow this poor website has to work out which reply is associated with which redirect. Well, it does it through the WCTX. So the website sets WCTX, makes the redirection, gets the reply back, and associates the two together. So we've got the action, we've got the security realm of the relying party, we've got WCTX, which remains unchanged, and then we've got the timestamp, which may or may not be there. It doesn't have to be there in the protocol. So we hit the ADFS server authenticates us. It now needs to return the token to us. And remember, we're just a dumb, stupid browser. So all we can do is standard HTTP. So we hit the website. We got a redirect to the ADFS server. ADFS server now wants to give us back a token. So what it does, it gives us back a page. And inside that page is a hidden web form. And inside the hidden web form is a token. All right, and it tells us to post it back to Thank you. Is that better? Yep, working. Good. Thank you. If you want to look at the claims, it begins with a SAML assertion and will also end with a SAML assertion. But notice the WCTX is in there, the X509 public key that did the signings in there, and we've got the submit button and the JavaScript. Whole bunch of cookies involved, and sometimes we have problems with cookies. When we authenticate to the ADFS server, right, number one, the ADFS server is going to give us back a cookie based on how we do the home realm discovery. So if we've got the STS, which is federated with multiple other STSs, we will make a home realm discovery choice, and our choice will be put into a cookie, and that cookie will be persistent by default. So next time we won't be asked about home realm discovery. We've got an MSIS authenticator, which basically means you are authenticated to the ADFS server, which means that if you go back to it again, right, you will not have to supply your credentials. And if you think about ADFS server, one relying party application, another relying party application down here, we hit the first relying party application, up we go to the ADFS server, authenticate, gives us a cookie. We hit the other server, up we go to the ADFS server. We don't longer need to authenticate, we just pass the cookie back and we're automatically authenticated. So once we've signed in, we've got SSO across all relying parties. There's another cookie which is MSIS authenticated, which gives us a time and date of authentication. We got an MSI sign out cookie, and what this does is it collects together a note of all of the relying parties we've hit. So we hit relying party 1, we go up to our ADFS server, and in that cookie, which is the MSIS sign out cookie, it will say you have just gone to relying party number 1. When we go to relying party number 2 and we go up and automatically authenticate to the ADFS server, it extends that cookie. It says you've now gone to relying party 1 and relying party 2. If you go to number 3, puts number 3 in there. And the reason it exists is so that we can do a federated sign out. So when we sign out, we can say, oh, well, you signed into this one, and this one. We'll send a sign out message to each of those guys. So we can do a federated sign out across all relying parties in our environment. The next one is MSIS loop detection, and if you find that you get a loop detection failure, right, very, very typical loop detection failure is you hit the website, right, you go up to the ADFS server, you come back to the website with a token, you pass the token to the website, and what that does is it turns the token into cookies so that when you come back to the website, right, those cookies are used to authenticate you. So what can happen is, well, in fact, what happens, let's do it when it's working. Website, ADFS, website with the token, website again with the cookies that were set the first time, page back. All right? So if something is wrong with the cookie setting, what can happen is you come to the website, you go up to ADFS, you come down to the website, present your token. It doesn't set the cookies properly, so next time you come back on the redirect, it says, you're not authenticated. Up you go, down, up, and you just bounce back and forth like that, and you just do that forever. All right? So what the last cookie there is the MSIS loop detection cookie, is it basically says, if you do this 6 times in rapid succession, I'm going to time you out and kick you out and say there's something wrong. So if you see something about loop detection, it is quite likely that the website is not happy with the token, or it is not issuing cookies correctly. Maybe somebody's fiddled with the lifetime of the cookie and set it too short. So it actually gets set, but by the time you come back on the redirect, it's already expired. So literally, you know, someone's made a mistake and set it in milliseconds. In terms of what cookies does the web app use, it sort of depends on the web app. But basically, I'm going to present a token to the web app, and it's going to take that token, could store it internally, and give me a reference back to it. So it's cached the token internally and gives me a reference back as a cookie. Or what it can do is take the contents of the token and serialize it into a number of cookies. Absolutely essential tool, Fiddler. How many of you use Fiddler? Okay, it's probably about half of you. You all need to use Fiddler or something of Fiddler's capability, similar capability. It's an extremely useful tool. You can also put additional inspectors into it so you can actually look at things in different formats. Fiddler, if it's all of this traffic is HTTPS. And Fiddler will sit as a man in the middle, right? So what basically Fiddler does is it does HTTPS bridging. So it spoofs you a certificate. So you've got the client. This is the client now running Fiddler. Fiddler becomes a proxy on the client. So when the client goes out from the browser, it will go through Fiddler. So when it makes any HTTPS requests, they can be routed through Fiddler. And what Fiddler does is it terminates the HTTPS, inspects what's being sent, and then reestablishes the HTTPS, right? And that all works absolutely beautifully, except, well, no, there's two things you need to know about. Number one, you are spoofing certificate. You are capturing people's information that they put in the browser. So if you do have to ask someone to do this remotely, and we've had situations where we've had developers all over the world working towards coming towards one federated portal. And some developers have been having troubles. And we've got them to do is run Fiddler. All right? They run Fiddler. They send us the trace so we can analyze it. And in that trace, of course, is the username and password. So what you've got to do is be very aware of that. And after you've done your debugging, get them to change their password immediately. Otherwise, if there's suddenly a breach using that username and password, people could be pointing fingers at you. So do bear that in mind. Secondly, is this doesn't work by default now with the latest version of ADFS. The reason being, what it does, ADFS now uses a thing called channel binding token. And what it is, when you authenticate through an SSL tunnel, it binds the authentication channel to the SSL tunnel. All right? So now Fiddler terminates that. All right? So then it reestablishes the tunnel for you on the other side, and that binding has been lost. All right? So when we arrive at the server, the ADFS server looks at it and says, channel binding, it does not, or the binding between the authentication channel and the SSL channel doesn't match. I'm not going to log you on. All right? To get around that temporarily, you can do set ADFS properties dash extended protection token check none. All right? If you do that, make sure you put it back on again after you've done your troubleshooting. There is an alternative. What you can do is you can get Fiddler to inject credentials. So effectively what it does is it re-authenticates when it puts the whole tunnel back together. But I mean, I put a reference in there if you want to look at that. There's a little bit of dev work to be done for Fiddler. Fiddler inspectors, you can download an inspector. There's a particularly useful one which comes off Codeplex, and what that will do is it will allow you to actually see the contents of your web page that's being returned, and inside the returned web page is the SAML token. Okay, so what I want to do is a very quick demo using Fiddler, and I'm going to be starting off here on my server 1, because what I want to do is let's find server 1 this way. It's the simplest way. I'm just going to do a break claims on this, so I'm going to run that as the administrator. That's done it. It's broken. Okay, so I'm going to come to my client and my client machine, and we'll just log in. The client is currently on London, and what I'm going to do is I'm going to use Fiddler in this particular case. Actually, what I'll do, let me just do this first. Let me just cancel that. I'm going to blow out the I've actually got the home realm on this, so I'm going to blow out the cookies, the persistent home realm cookie. I'm going to start Fiddler. And now what I'm going to do is I'm going to go to my claims application. This is the home realm discovery. I'm choosing example. I'm coming in here, so example John. And I'm getting an error message. Okay, well, it's sort of fairly obvious the error message is from the server, but you know, it's not always that obvious. So let's actually look at this trace to see what we've got. We hit server 1, okay, and what happens here, if we look at the headers, we actually get a redirect. I'm just going to send that to the text wizard, and I'm going to use Notepad to pop that in. Okay, are you okay at the top? You can read that, all right? Yeah, great. So this is the redirect that we saw in the notes. Okay, so it's being redirected to this point here. It's doing a sign in. We've got the the realm, which is the sort of relying party identifier, and we've got the WCTX. So the next thing happens is that we actually go up to ADFS. So we're hitting that endpoint on ADFS. ADFS gives us back a 200 OK. If we look at that with WebView, we actually see that it's the home realm discovery. So this is the home realm discovery that's coming back. So we then post back the answer to that, and if we look at that in web forms, we can see that that has actually gone back to adfs.example.com, and this is where we go. That's our home realm that's been discovered. That will also go into a persistent cookie. We authenticate, which is the green here, and having authenticated, what will happen is we will get a whole raft of cookies. So these are all the cookies that are now set, all right? And some of these are base 64 encoded. You can decode them if you want. And then what's happening is at the same time, we're getting a 200 OK. And if we look in text view, what we can see, push that into Notepad, what we can see is that we've got a form, it's post. Where's it going to post it to? It's going to post it to server 1 claims, right? It's hidden. And down the bottom of this thing is we've got a submit button, and we've also got a little bit of JavaScript for automating the submission. So if we look at that in WebView, what we'll actually see is, oops, sorry, wrong, let me close. If we go to WebView, we'll actually see the submit button down there. But of course, that's automated. Now, buried in this slot, if I want to do a find on there, and I do a find looking for John, what we see in there is john@example.com. And what's that? That's his UPN. We can find the next. And here, this is the attribute. Well, that was the, go on, find the next. Here we got example/John, and that's his name, and so on. So you can actually see the contents of this, the SAML token coming back. Much nicer way of doing it, of course, is to use this inspector, which is the Federation inspector, and we can actually see all of this information coming back, including, oops, sorry, didn't mean to do that, including this guy's sort of group membership, etc. Okay, So the next thing is we then hit the SRV1 claims, and this is giving us back a 500 internal server error, which brings us back to this message here. Now, this is a little bit obscure, this message, but if we look at it, we might be able to glean something from it. Sort of no mapping for security token, and then it goes on and down here, no valid key mapping found for security token. So you can sort of guess that it might be something to do with the certificate. So what certificate is actually signing it? Well, again, we can use Fiddler to find that out, because if we actually go in here down to our federation, we can actually pull the certificate out of this stream, which is there. If I pop that into Notepad, you can actually take this certificate here. Let's actually let me do this. Let's open a new Notepad. Pop that in there. Having taken the certificate, what we can do is save that, and I'm going to save it to my desktop as a cert.sir, and we can then open it up, and you've actually got the certificate. And if you look at this, you look at the details on this, you'll see that the thumbprint is D6, let's just take that up, is D6 DCE5 is the thumbprint. And if we look at the client machine, so we look on server 1, and if I go across to server 1, I can look in the web config on server 1. So we can come down under, where are we? Root C drive, iNet. If we look at the web config on claims, and if we go down there, the thumbprint of the certificate it expects is buried in here. It's 1E19, wrong certificate. Okay, so what we can do is we can go across to our ADFS server, because I could take it. I now know what the thumbprint is in that claim, but is it genuine? I need to go back to the source, which is my ADFS server, which is here. And what I can do on my ADFS server is use a bit of PowerShell. Is that a PowerShell script? Yeah. So get ADFS cert certificate, and the certificate type is going to be the token signing, and there's the thumbprint. So the certificate's probably rolled over, all right, but nobody's updated the relying party. So if I grab that thumbprint and put that into my web config file on my server, where's my server gone? There we go. Let's put that in there and save that. What we can do is come back over here to our client and give that another go. And in fact, what I'm going to do is, let's just drop that down there. We'll close that. We'll clear out Fiddler, and then we'll go to claims again. So this was all working before, of course, remember. It's John and we're through to our server, and it is now working again. So what I really wanted to do was show you this. So we've now got it, we've presented it back to the server. So the server responds by taking the page that was presented to it. So we look at that, it's a post, that's the post of the page. It sets its fedauth cookies, and then the next job is that we actually present back the cookie, or the fedauth cookies that were set, and then as a result of that, we end up with the page being rendered. So we go to web view, we get the page back. key message here is that you can get in, you can see all the protocols, and even if it's a sort of SAML protocol, OAuth 2 protocol, it's a sort of similar thing. You get into the habit of it's being redirected. Is it going to the right endpoint? Having gone to the endpoint, is it looking for something to do with the right relying party, and so on. So you can sort of turn it into a more generic flavor. If we look at the Web Application Proxy, what the Web Application Proxy does for us is it allows an incoming request to be proxied straight through to a web application. It allows an incoming request to come in and be authenticated on the edge. So to authenticate before you even get through to the web app, what you've got to be is claims authenticated. Right? And then what we can do, if we want to, we can actually go through to our claims app. Having got through to our claims app, what will happen then is we will get to the claims app. The claims app will say you're not authenticated. Send us to the ADFS server. Well, we've already authenticated with the ADFS server to get our claims. So what will happen is we will pass the cookie to it. We will then get authenticated there, and then we'll come back and we'll go straight through to the application again. Right? So there's that authentication process that takes place. Another thing you can do is you can do Kerberos constrained delegation. And here we come to the edge, we get authenticated using claims identity, and then using Kerberos constrained delegation, what it can do is it can translate our identity to a Windows identity to go to a Windows backend system. Right? The caveat of that is that your proxy will need to be domain joined. Right? For all other interaction, it doesn't need to be domain joined, because basically it authenticates against the ADFS server using the certificate. But if you're going to use KDC, then it must be domain joined. Proxy tokens, there are many, many types of tokens around. The SAML, SAML's fairly heavyweight, so there was a simple web token created. That really wasn't considered good enough, so today the main token type that's used in an enterprise environment will be a SAML token, but in a more consumer style environment and for things like devices, it will be using JSON web tokens. So what I want to do is, I don't want to look at Kerberos constrained here. What I want to do is actually go and actually look at the WAP in action, and we won't do the Kerberos constrained because that will take us too long. But just to quickly look at the WAP in action, if I go out onto my internet here, and I just need to change the settings on my client. I'm going to switch the client to the internet, and I'm going to come down here. Okay, I'm going to clear that out. Let's take that full screen again. And let's go to my claims application. All right, you notice that immediately it's using forms authentication, so because we're coming now through the Web Application Proxy. Sign into that. And a nice claim is we've got this claim here, which is down here somewhere. Inside corporate network is, well, I would have expected that to be false. Oh, I'm looking at the wrong thing, am I? Probably. No, hang on. Let me just clear that out. Let's do it again. I think I left the session open, and that was the problem. So, example, John. Right. So let's come down here. And what I'm looking for, yeah, that's better. Inside corporate network is false. So it tells you whether you've come in from the outside world or you've come in from within the corporate network. And if we look at the trace, what we can see is we hit we hit SRv1, but actually we're hitting the proxy. And we get a redirect back, and if we look at that redirect, let's just take this redirect and send it to the text wizard and pop it in next to our previous redirect. And it looks a little bit different. But, as I said to you, similar. This is actually a proprietary protocol that's used for getting through the Web Application Proxy. It's very similar to OAuth 2, though. And what it's doing is it's sending up to the ADFS server, saying the action is sign in, and the realm is the app proxy. So it's actually asking for a token to get through the app proxy. Right? And if we look at the reply to that, so having authenticated, well, let's go through this process. So we're getting a redirect. We're coming to here. We get a 200 OK. And if we look at the web view of that, that is we're now being prompted for our username and password. At this point, we pass it back. This is web forms. So if I show that as a web form, I can actually see my username and password going back. I get authenticated. And then what happens is at this point, I pass back to the client an authentication token. So I'm going to send that to the text wizard. Right. I hope. I'll actually copy that. Let's pop that into Notepad. And this is the reply with an authentication token. And what you can do, if you want to translate these are JSON web tokens. You can go and use something like there's a JSON web token decoder from Google that you can use. And provided I've got an internet connection, which I'm sure I did have. Oh, doesn't seem to. Oh, no. I think they turned off the internet because they're. Anyway, what you could do is if you can actually translate that, and it will show you it's the token to get through the Web Application Proxy. I then get through the Web Application Proxy, and I'm getting a redirect here. And this redirect, if we just look at that, we send that to the text wizard. This is the redirect we've seen before. So now we had the redirect for the token. We've now got the redirect, which is the same redirect as we had previously. All right. So it's basically now the web server inside saying, you're not authenticated, off you go to ADFS. But at the same time, what's happening is when it's sending us off to ADFS, it's setting an edge access cookie. So now we've got a cookie that we can get through the WAP with. So off we go to ADFS. We don't have to sign in again because we're sending our cookies up to ADFS. So if we just look at the headers on that, we've sent the cookies up. And then we come back to the server with the edge access cookie. And also it's a post of our SAML token. And then what happens is we get the fedauth cookies set. Oops. So we got the fedauth cookies set here. And I meant to do that as the fedauth cookies being set. And then we come back again. This time, we look at the headers with the fedauth cookies and the edge access cookie. So we've come in and got through. So bottom line of all this is you really can see what's going on. The thing is, don't spend, and I see people do this and organizations do this, they spend absolutely hours trying to fiddle around with things, right? And it's just not working. But they're not taking the tools out that you need to get it working. So Fiddler, primary tool. I think a network monitor is always extremely useful. I mean, we saw how it sorted out the SSL, in a couple of minutes. If you decide to put your web application proxy out into the DMZ, the number of times I've seen the wrong firewall settings being implemented and therefore the connection failing between a domain joined and, if we put the Web Application Proxy to support KDC, Kerberos Constrained Delegation, we've got to open the appropriate firewall settings so it can talk to the domain controller. I've seen people fiddle for days with that, and just putting a network monitor on, you immediately see that it's not being able to communicate on a particular port. And you can immediately say, well, that firewall rule was wrong. I've had people say, no, the firewall's perfect. And then you say, well, there's an ACL on some router somewhere, right? And invariably, you find the ACL and fix the problem. So it's using the right tools to fix the problems. If you make changes, do remember to switch them back after troubleshooting, particularly if you put on some of the advanced logging. I'm always available as a consultant. I love coming to Norway, so anytime you want to ask me over, that's absolutely wonderful. And this brings me to my third year at NIC, actually, the end of it. And hopefully I will see you back next year. And thanks very much for coming to the session. Thank you. And if you've got any questions, by all means, come down and ask away. Thanks, bye-bye.